Welcome to APH's Access Academy. Once again, it is today UEB Math Science Frozen Juice Concentrate. What do we mean by that? Well, just like frozen juice concentrate is portable and packed full of flavor, so are the principles that make up all UEB math and science materials. And I am so happy to welcome back APH's very own Kyle DeJute, who is with us today.
Thanks, Amy. Let's dive into the juice. So I'm Kyle DeJute. My official title at the American Printing House for the Blind is Braille Trainer. That basically just means I get to push up my nerd glasses about Braille questions, especially Braille code questions, which I'm really excited to talk about today. The picture of me on the screen in this slide is me. I'm a white woman with short curly brown hair, sort of in a strip of curls down the middle of my head. And this particular picture has another face in it, which is my 5-year-old who's peeking over my shoulder. That's actually happening today. My kid is home, but I don't expect any interruptions. So we get to really bathe in the juice of UEB math science concepts. Some of the takeaways for today include UEB Math Science and UEB are the same code. So UEB for literary materials and UEB for technical or math and science materials. It's all one unified English Braille code. We're going to talk about a line through previous item indicator. So like a cross out and how it can sort of save the day. We're going to look at the APH math symbol reference booklets, talk a little bit about how they're laid out and how easy it can be to get them. First off, let's talk terminology. I can't cover all of the jargon that we might say today, but I definitely want to talk about one terminology decision in particular about UEB and Nemeth, and about our code books for that all one unified English Braille code. So on September 21st, 2020, the Braille Authority of North America, or BANA, officially adopted the document entitled Terminology. See why this section is titled Terminology, UEB Math/Science and UEB with Nemeth. So again, that's UEB Math/Science and UEB with Nemeth. So these are the recommended terminologies for the two different ways that in the US we transcribe math and science material. And it's meant to distinguish what's transcribed according to guidelines for technical material, the full UEB code, as opposed to when Nemeth code is used within little bubbles defined by switch indicators, and the greater context is in UEB. So those are the two options in the US. It is my understanding that no other English-speaking country has retained the use or has adopted the use of the Nemeth code for math and science. So this distinction between the two UEB Math Science versus UEB with Nemeth is a US thing. So again, the BANA approved, the Braille Authority of North America, the US and Canada. The BANA approved terminology for that transcription, any transcription created by following the rules of UEB, which includes the guidelines for technical material, is UEB Cap Math/Cap Science. I just want to touch quickly on Nemeth code is a separate Braille code from Unified English Braille, which was designed in the mid-20th century by American mathematician Dr. Abraham Nemeth, who is a member of APH's Hall of Fame. Conversely, what we're talking about today is the guidelines for technical material and some of the guidance given therein, which builds on what's in the Unified English Braille rules of UEB. The guidelines for technical material, again, is an additional part. It's like a supplemental volume to the rules of UEB. It's not a separate code. And they reference back and forth to each other as well. Every once in a while, the rules of UEB will send you to the guidelines for technical material, and regularly guidelines for technical material will sort of say, hey, here's some more information about line mode, for example, using Braille cells to sort of draw shapes when we absolutely have to and can't get a tactile graphic. And when guidelines for technical material talks about line mode, for example, it basically says, hey, these concepts were introduced or are introduced in rules of UEB section something. And here's more information about it, because one more time, the guidelines for technical material is part of the greater unified English Braille code. It's all one code. The guidelines for technical material is in the process, continuing process of undergoing revision and improvement. On the website of ICEB, which is the International Council on English Braille, there's a section on guidelines for technical material, which includes some updates that you can download. Very important update is the section 3. So this is a replacement section 3 for the guidelines for technical material. It's available for download in PDF, BRF, and Word form, and it gives a streamlined, expanded, and more user-friendly version of the discussion of operation and comparison signs. So your pluses, your minuses, your greater thans, your less thans, all of those are talked about and covered in a very nicely laid out, updated section 3 of guidelines for technical material. And then there's a couple of other updates, which it's the perennial question of how do you add those updates to your code book? And it's up to you. It depends on how you use your code book. If you have a hard copy, why then you got to print out the updates and put it into your hard copy. If you use a PDF, you could perhaps insert these updates as comments in your PDF. But I don't want to leave here without saying the guidelines for technical material has this amazing group of people reviewing it and working on making it stronger, faster, better. And it's regularly getting updates, which are always published on that ICEB page. Okay, so there's a multi-tool picture up on the screen, or a Swiss Army knife picture up on the screen, because one more time, I'm going to say UEB is all one code. So even when we're transcribing math and science, we're still transcribing in UEB. Even when we're looking to the guidelines for technical material for information, that is building upon and specializing some of the rules in UEB. They're all one code, not separate. So here is our first poll. Question is, what is the BANA recommended terminology for a transcription created by following the rules of UEB, including the guidelines for technical material? Is the BANA approved terminology math and science, UEB math/science, guidelines for technical material, or UEB with Nemeth?
We have about 38, 39, 40% reporting. And I'll go ahead and share out what you all believe the answer to be. And Kyle, we have 76% that have reported UEB Math Science. We have 14% UEB with Nemeth and 10% guidelines for technical material.
You are totally right. The UEB math/science is the BANA approved terminology for a transcription that uses math and science symbols and is transcribed just according to rules of UEB, which includes the guidelines for technical material. So choice C, guidelines for technical material, is the name of the book or the collection of guidelines from ICEB that combine with the rules of UEB to make the rules that apply to a, quote, UEB math/science transcription. These terminologies are designed in the US to distinguish between UEB Math Science, which is just sort of specifying what kind of UEB is used, and UEB with Nemeth. UEB with Nemeth, the goal of that terminology is to specify that it's UEB. It's not like a transcription that was done in 1990 according to just the Nemeth code and the way that it worked with English Braille American Edition. That's why the UEB with Nemeth terminology is arranged the way that it is. But today we're just talking about UEB Math/Science. Let's start with a pretty little dot configuration. Dot 4, dots 1, 5, 6. This is the line through previous item indicator. What does it do? You might notice I'll come back to what you might notice about the title of this slide in a moment. What this indicator does is it tells us there is a line through the previous item. So item is carefully defined in the guidelines for technical material. And we're going to talk in a couple of different pieces about some of the definitions of an item. You might notice in the slide title here that we're talking about the line through previous item indicator, which is 2 cells, dot 4 and dots 1, 5, 6. But in the title of this slide, there are 4 cells. And that's because here where we're talking about the line through previous item indicator, and we're not using it to put a line through something, we've preceded it with the dot locator for mention, which is 2 cells, dots 4, 6, and the full cell. That's all that's happening in the title. That's kind of cool. The line through previous item indicator is preceded by the dot locator for mention. This is the same 2 cells that we use to precede all of our listings in the special symbols page. It helps the Braille user know where in the 3 rows of the Braille cell a dot is falling. It gives a point of reference for the full size of the Braille cell, that dot locator for mention. So yeah, the line through previous item indicator says crossed out, essentially. For example, when something is not equal to, we have the equal symbol from UEB, that's dot 5, dots 2, 3, 5, 6, and then this line through previous item indicator, so that our not equal to is comprised of 4 Braille cells. And it looks like the equal sign with a sort of top right to bottom left slash through it. The Unicode number for the not equal to print character is 2260. And the name, official name of this symbol is not equal to. And a sort of description is a cancellation line through and equals. This information, the Braille cells, the print symbol, the Unicode number, and a Unicode name, as well as possibly a description, is the way that the new Section 3 of Guidelines for Technical Material is laid out. And this is cool for a couple of reasons. Not only does it just give us lots of data to hold on to, but it's also true that the print entered in that Guidelines for Technical Material, especially Section 3, you can copy out that symbol and it is the Unicode symbol. It's not like a picture of a Braille symbol. It's the actual symbol that you can put into a lot of Braille transcription softwares and get exactly the Braille cells that you're expecting. Similarly, the other way around, if you have a print symbol and you want to know if it's actually the one you want, knowing what the Unicode value that you want is can let you figure out what print symbol you're looking at in an electronic document. So maybe you paste that print symbol into Google, or if you're in Word, you Alt-X when your cursor's right after it. That reveals the Unicode number. And you can compare it to the Unicode number that's listed in the Guidelines for Technical Material to see if your electronic file has the same print symbol that Guidelines for Technical Material is talking about. Okay. I'm gonna like sort of push down instead of pushing up and getting nerdy with my glasses about this layout and wealth of information in the new Section 3 of Guidelines for Technical Material.
Before you move on, just one quick question. Is there also an ASCII symbol for these items?
Sure. For every Braille cell, there are corresponding ASCII characters. And the Braille cells that are listed in the guidelines for technical material documents are actually ASCII. So if you sort of copy them and paste them without formatting into a word processor, then you're getting the ASCII characters that correspond to the Braille cells that make up whatever symbol you're looking at. We talked a lot about ASCII in a recent webinar called How Braille Works Electronically. And I think what I said about copying those Braille cells from the guidelines for technical material, PDF or Word, copying those and pasting them unformatted, like with no font applied in order to see what the ASCII characters are. I think that if that doesn't make total sense to you, then watching the How Braille Works Electronically webinar will help that make a little more sense, because ASCII is really cool and also a little counterintuitive to those of us especially who look at a Braille cell and immediately think about its meaning. Thank you for asking. This is March when we're doing this webinar, which is Women's History Month. So a couple of our examples here are accompanied by a picture or reference that is associated with an amazing woman. So on our slide here is Chanel number 5, because Coco Chanel designed some amazing and beautiful materials, as well as building up a company and a line that we still use materials from. And my kid is really excited about Coco Chanel and told me the other day, I'm never going to wear a corset because, like Coco Chanel, I want to be able to move and do things. And I said, that sounds great. So with the smell of Chanel number 5 in our brains, let's look at a not equal to example. 2, and then we have a cross multiplier, a little X multiplier, 2, not equal to 22. So the Braille for this is going to use our UEB symbol for the multiplier, sometimes called the cross multiplier, that looks like a little X in the middle of a line. And we're going to use our 4 cells for is not equal to in order to say, hey, here's the equals, and then there's a line through. That's how it's constructed. Our 4 cells for is not equal to are dot 5, dots 2, 3, 5, 6. That's just the equals. And then our line through is dot 4, dots 1, 5, 6. While we're here, let's note some other aspects of this example. The numeric indicator happens before the first 2, so it doesn't mean B. Our cross multiplier is dot 5, dots 2, 3, 6. And then we have another numeric indicator so that our next cell, dots 1, 2, means the Arabic numeral 2. Again, our 4 cell is not equal to, and then numeric 22. A cool place to practice to flex your UEB Math Science muscles is in the UEB Online math programs. So lesson 2 in the math program, UEB Mathematics Introductory, talks about operation and comparison signs, including not equal to. We have any burning remaining questions about not equal to or potentially UEB Online or our Chanel number 5 example?
We are good to go.
Where we're going next, look, I don't want to be negative, but it's all about canceling. We show cancellation with this line through previous item indicator, right? Just like on a chalkboard, if you were doing a math problem where you had to carry or borrow, you would a line. That's my chalk on a chalkboard sound. You would align through the thing that you're crossing out and replacing with something. There are examples of this in Guidelines for Technical Material 4.1.6. If you want to bathe in some juice over there. Here are some of our examples. And again, it's Women's History Month. So this example is accompanied by a photograph of the ballet dancer Alicia Alonso, who not only had an amazing ballet company that she organized and built herself in she also lost her eyesight and consequently proceeded to dance an entire ballet performance. So Alicia Alonso is accompanying us for this cancellation example. The print of it is 42 over minus 29, then a summation or difference line, just the horizontal line, and then the answer 13. So the 42 has its 4 crossed out, replaced with a 3, and then the 1 we've taken away from that 4 in order to make 3 is a little guy right next to the 2 to make it 12. Again, we use our line through previous item for this kind of cancellation. So our Braille might look something like this, where we have a numeric passage. So we don't have to keep repeating numeric indicators, and we can focus on the content of this example. So our numeric passage starts with 2 cells of dots 3, 4, 5, 6. Then we have our 31, there we go, 30 and, or sorry, not 31, our 3 and our 1. The 3 is above the 4, and the 4 has the line through previous item indicator following it. The number 2 is spaced over from that, and that lets this little 1 here that's combining with the 2 to make 12, lets it be in a column of its own, because it's not replacing the 2, right? It's sort of combining with the 2, not just sort of, it is in fact combining with the 2 to make 12, from which we subtract 9 to get 3. And then we have our 3, which has replaced the 4, which is why we've brailled it directly above the 4, which is crossed out. The 3 gets 2 subtracted from it to give us 1. And that's how our cancellation subtraction problem is laid out. Let's talk about the tiny elephant in the room. The horizontal line here, the horizontal line mode is indicated with dot 5, dots 3, 5. It doesn't extend under the minus sign. And that's something the guidelines for technical material does, and is something that's not directly required by guidelines for technical material or by BANA. If you can imagine, the goal with the line that separates the problem from the answer is to be consistent. So either extend it so that it goes under your symbol of operation, which is over at the far left, or consistently don't include your symbol of operation. I think that's the best I can give on that. And then we did terminate our numeric passage here with dots 3, 4, 5, 6, and 3. Let's take a little moment to appreciate the juice concentrate nature of the numeric passage terminator or numeric terminator. Just like the italic terminator, the bold terminator, any type form terminator, right? It is the indicator followed by a dot 3. And that's one way that the UEB rules are expanded out from one concentrated concept. Terminators have their cell following the indicator is dot 3.
So Kyle,
yeah.
Is it wrong to put the 1 directly over the 2 in the first column?
Is it wrong to put the 1 directly over the 2? No, I'm confident that I have a lot of confidence in Braille users to figure out the subtraction problem, regardless of we arrange the cells or mess up the cells. Because if the 1 is directly over the 2 here, then we would have no space following the line through previous item indicator, which is fine. We'd still be in numeric mode because we're in a numeric passage. And so this cell dots 1, 2 would still mean number 2. And it would not be followed by any sort of crossing out indicator. And so it would probably be apparent to the Braille user that the 1 is being carried over to combine with the 2 and not replacing it because the 2 isn't crossed out. So yeah, it wouldn't be wrong to have the 1 directly over the 2. I would argue that this layout is a more accurate representation of the math that's happening here. And I appreciate that spacing spatial arrangements is hard enough when you're working in a transcription program and you're an electronic transcription program, and almost impossible when, not almost impossible, but really challenging when you're working on a Perkins Braille writer or with a slate and stylus. To space out these spatial arrangements is really an art, like ballet, which requires a lot of practice.
Just two more questions before we move on, if we can. Okay, so can the passage indicator and terminator be on the same line as the problem, or does it have to be above, below the problem?
That's an interesting question. The guidelines for technical materials specifically tells us that the numeric indicator and numeric terminator they can't be on the first line of the problem and the last line of the problem. So every spatial arrangement needs to be preceded and followed by a blank line, or a line with only the numeric passage indicator or the numeric terminator.
Okay.
So it would be appropriate to have the numeric passage immediately before the 3, for example.
Okay, so just one last thing, and we're going to keep on moving then. Is there a common strategy to teach a young student how to space their questions prior to solving the questions on their Braille writer?
That's a little outside of my wheelhouse. Okay. Unfortunately, I don't have a lot of experience with the hardworking Braille using students. The couple of Braille students or Braille users that I've worked with or seen are doing math, they do not lay out their math problems the same in this sort of ideal way that we try to put into a transcription for reference. That's all I'm going to say about that.
That's great.
What happens in the transcription is really ideal, and what happens in the real world rarely can be as ideal. It's about getting your hands dirty and getting the stuff in wherever you can.
I think that you answered that so well. That's great. All right, we'll go ahead and continue. Thanks, Kyle.
So here is another cancellation problem. This time we're looking at the Braille first, because we're that good, right? We know what the line through previous item indicator is, and we can see it in action, even those of us who are sight dependent and maybe more easily would understand the cancellation with print. So what's happening in this problem is we have 5, 0, 1 minus 2, 7, 6 equals 2, 2, 5. So in order to subtract 6 from 1, we had to borrow some help. Couldn't get anything from 0. So we had to borrow from our 5, and we crossed that out. We used the line through previous item indicator, dot 4, dots 1, 5, 6. And after we crossed out the 5, we replaced it with a 4, took that 1 that we borrowed over to combine with the 0. We made a 10, and that we crossed out the 0. So now we have a 10, but we still have to borrow from that. So we crossed that out, made it a 9, took that 1 that we borrowed, made an 11, and replaced that 1. So now we finally can go 11 minus 6 equals 5, and way up to the top of the middle column, 9 minus 7 equals 2. And make sure we're at the very top of what we have available in this column, 4 minus 2 equals 2. Yeah, okay, I let you cheat, those of us who are sight dependent, a little bit on this one, because I highlighted all the cells that are the line through previous item indicators. But I hope that the idea you got was essentially this that's represented in print, where we have 501 with all of those numbers crossed out. Above the 5 is a 4, above the 0 is a 10, which is also crossed out and replaced with a 9. The 1 is crossed out, and above that is an 11. And then our final answer is 225. All right, so before we leave this slide, please let me take a moment to focus on the women's history aspect of it. There's pictures of mushrooms And I won't ask you to guess because it's somewhat not common knowledge. The person who made these mushroom or mycology, the study of fungus illustrations. It's someone we know more for their illustrations of rabbits or bunnies. And it was Beatrix Potter, who was an accomplished mycologist and scientific illustrator. Beatrix Potter also happened to write Peter Rabbit and to illustrate those fun stories as well. And she did a lot of beautiful scientific work, observation, and illustration in the field of mycology, the study of fungus. Happy Women's History Month. We looked at the Braille and the print separately. Here on the screen is our most recent example where we have 501 with all of those numbers crossed out with the Braille and the print together. And again, we've opened our numeric passage on a line by itself because every spatial arrangement has to be preceded by a line that's totally blank or has only the numeric passage indicator on it. And at the end of our spatial arrangement material, on a line by itself is the numeric terminator. Okay, please engage. It's time to have a poll. This is a sort of test your knowledge one. Which is the correct transcription of the expression 5 multiplication 3 not equal to 53? Your first answer option is, and these are going to be shown in the poll in ASCII Braille. So you're just going to see the print symbols that correspond to these Braille cells that are up on the slide in your actual poll window. I'm not going to read them out because that's just confusing. I'll let you look at them for a moment and find the right transcription.
Now, if you read them out, does it give it away? Like once they have an opportunity to feed in, just so that we have it in the recording, especially for our individuals that are not able to see, does it give it away if you speak it out?
No. Here's what we can do is I'll tell you the place where these three options are different is in the symbol of comparison. Option A shows .5, dots 2, 3, 5, 6. Option B shows dots 4, 5, 6. Dots 3, 4, dots 5, dots 2, 3, 5, 6, dots 1, 5, 6. And the third option, choice C, shows for the symbol of comparison, dot 5, dots 2, 3, 5, 6, dot 4, dots 1, 5, 6.
And what I can share is that 87% of our friends that are with us today chose option C.
Correctly. Yeah, our not equal to symbol is dot 5, dots 2, 3, 5, 6, and then the line through previous item indicator, which is dots 4 and dots 1, 5, 6. The answer choice A just has a regular equals sign, not the not equal to. And answer choice B shows a slash and then the equal and just dots 1, 5, 6, which here probably would be misread as the line over previous item indicator, which we're going to look at. And while we're here, can I please just highlight that, come back. There we go. Answer choice C is correct. And all of these answer choices are using that X multiplier. It looks in print like an X floating in the middle of the print line, and that is dot 5, dots 2, 3, 6. Are you noticing a pattern with our operation and comparison symbols? A lot of them start with dot 5 and then are followed by a more specific cell, which gives information about what symbol of operation or comparison we're dealing with. But they often start with dot 5. Please let me take a moment to distinguish the cross multiplier from the dot multiplier. They're two separate print symbols and they are two separate UEB symbols. Again, that cross multiplier is the dot 5. And then sometimes we call it the lower h, but it's dots 2, 3, 6. And the dot multiplier is dot 5. And then the lower 4 or lower D, it's dots 2, 5, 6. Those are in the updated section 3 of guidelines for technical material. One other way of sort of over applying UEB rules is for this example would be to use the line through previous item indicator and some Braille grouping indicators around the equals symbol. So this is not correct, right? Our correct answer would be what we said, the 4 cells for the not equal to. But if we had the line over indicator and then some grouping indicators, or the line through previous item and grouping indicators around the 2 cells that make up the equals symbol, it's overkill and unnecessary, because the equals symbol is a symbol unto itself. It is a single symbol of comparison, and so it is an item. And even without the Braille grouping indicators, it is clear and appropriate that the line through previous item indicator applies to the whole equals sign. The equals sign just happens to take up 2 Braille cells. Let's look at another example with lots of individual, or an example with even more individual symbols and UEB stuff. So before we do so, let me take a moment to nod to Women's History Month interesting person, Diane Shore, a blind, but who cares, jazz pianist with an illustrious, accomplished career. And may I just say in this picture, a fabulous bright red smile. Ready? Maybe you need to put on some jazz to refresh your brain while we delve into another UEB Math Science example. This one includes an angle symbol and this line over or bar over some letters. Yeah, this is a geometry example. An approximately equal to symbol. This specific symbol is the equals with a tilde over it. Also, an approximately equal to symbol. This one is a tilde over a tilde. And then one more thing, we have a bar over the numeral 7, which is part of the greater number 0.7. So our transcription for this, I have it formatted on the slide in a sort of nerd glasses following BANA recommendations way. For formatting, BANA recommends using only indented paragraphs, and information about that is given in the guidelines for transcribing mathematics using UEB. It's a publication from BANA. So starting in cell 3, cap consider, then our angle symbol, which is dots 4, 5, 6, and 2, 4, 6. Our letter, or sorry, grade 1 symbol indicator, capital B, period. Let's move on before I get really excited about grade 1 mode. Then our cap AB is grouped with Braille grouping indicators. So the opening Braille grouping indicator is dots 1, 2, 6, and the closing Braille grouping indicator is dots 3, 4, 5. Do those look like any part of any punctuation that you recognize, perhaps? We'll come back to that. So AB is grouped together, and it has simply a line over, not a line through, which is dots 4, dots 1, 5, 6. The line over, or bar over, is dots 1, 5, 6. That's it. So our specific symbol, and yes, I have to look this up every time in the new guidelines for technical materials, section 3, the symbol for this equals with a tilde over is dot 5, 4, 5, 6, and 3, 5. Then our BC is grouped, capitalized and grouped, and has a bar over. Our specific symbol for the tilde over tilde is dots 2, 3, and 3, 5. And then we have the new number 0, decimal. Then we have to group our 7. That's interesting. To have a bar over it. And we terminate the grade 1 passage, which we started way back at the beginning, so that our Braille grouping indicators couldn't be misread as GH and AR. And also, if we weren't in grade 1 mode, our line over indicator would be misread as WH. I mean, we'd be a mess, right? No, we got to put ourselves in grade 1 mode so we can have A and B grouped together And that's so this line over will apply to both letters, because just the item would be the previous letter otherwise. So we have to group together the two letters in order to make them an item. I feel like a gossip columnist. We're making A and B an item by grouping them together. Similar for BC. If we didn't group together BC, then the line over would only apply to the C. And that would be confusing and incorrect because we're talking about line segment BC, not, I don't know what, B with C repeating? I don't know. Our 7 has to be grouped. So for sort of the opposite reason that our letters had to be grouped. So the letters have to be grouped together because a single letter is an item. This numeral over here that's part of a larger number has to be grouped apart because an item is a whole series of digits, including decimals and commas. So if we didn't pluck out that 7, then the line over would apply to the 7, the decimal, and the 0. These Braille grouping indicators around the 7 are narrowing the effect of the line over indicator. And the Braille grouping indicators around the BC and the AB are expanding the effect of the line over indicator. That's sort of narrowing and expanding and multiple pieces working together to give us one beautiful and accurate expression is why I inserted Diane Shore, a jazz pianist, onto this slide, because that's similar to what happens in jazz. Lots of pieces moving together in a complex and changing way to give us a beautiful, complete product. I said the word item a lot. I also said earlier that it is a foundational or key to UEB and carefully defined in the guidelines for technical material. So the term is defined in sections 7.1 and 12.1 of the guidelines for technical material. And you know what? Let's be very responsible and open it up. Because I regularly think that I have something from the rules of UEB, which includes the guidelines for technical material, memorized, and then I find that I don't. So I'm just going to search for 7.1. And I'm going to redo it because my Adobe Reader was not fully loaded and said, oh, you wanted to search for just 7? Great, let me help. Nope, don't help. I want you to take me to 7.1. Good, then I can link down to the section at 7.1 where we have the definition of an item. And you can see there are 8 points here which give specific information about what an item can be. One of the things we already touched on, which is an entire number, right? We had to narrow the focus of our line over indicator in that 0.7 because an item without special instruction from Braille grouping indicators is the entire number. So the numeric symbol and all the other symbols in numeric mode. Another definition of an item is, sorry, lost my mind, a general fraction, right? A whole fraction, a whole radical expression, an entire arrow, and any expression enclosed in matching pairs of round parentheses, square brackets, or curly braces. So this is the punctuation that I was trying to refer to earlier. The Braille grouping indicators are dots 1, 2, 6, and 3, 4, 5. And the round parentheses is just those two symbols, but each preceded by a dot 5. And the square brackets are just, and curly braces are just those grouping symbols preceded by a cell that says, hey, this is grouping something together, and it's specifically this shape of punctuation. There goes UEB again, taking a basic indicator and then expanding it out to mean different things, either Braille grouping or a specific grouping punctuation. So after we've responsibly looked at our guidelines for technical material, what does apply to an item? So some of the things are these bars over that we often see for line segments or repeating decimals, but dots over as well, which again is often used for repeating decimal. There's also specific modifiers for a caret and a couple of other things. Those each apply to the preceding, quote, item. Things that are written directly above or directly below, modifiers directly above or below, apply to an item, because it's a foundational concept, especially of the material that guidelines for technical material applies to. Other indicators that apply to an item are superscripts and subscripts. We already talked very specifically about what the symbols were in the Diane Schur example. So let's talk about symbols, because we just talked about at least two kinds of symbols, right? There are those grouping indicators, which logically expand to the parentheses, the square brackets, etc. There's also those like symbols for the tilde over tilde, but a different symbol for the equals with a tilde over it. What's an easy and practical way to look up those symbols without always pulling out the full rule book? The math symbol reference booklets from APH, they come as a set. One is a UEB math symbol reference booklet. The other is a Nemeth Code math symbol reference booklet. And both of them not only give the information that's sort of laid out, like in the new section 3 of Guidelines for Technical Material, where you have the print symbol and the Braille cells that it corresponds to. These math symbol reference booklets also include a column where you can see the symbol in use in an example. Each booklet is, a 1/2 inch thick in print, and I want to say like 1 inch thick in Braille. And they're pretty easy to carry around. The print versions are spiral bound and color coded according to whether a particular symbol most often happens in beginning math, which is orange, intermediate math, which is blue, or advanced math, which is green. I like these reference booklets. I know a lot of love and interest went into laying them out, making them easy to reference, and also including some illustrative, accurate examples for each symbol that's defined. And it's not just symbols of operation and comparison. There's also, I think, examples for like grouping indicators. So again, the math symbol reference booklets from APH come as a set with 2 booklets. That's how they always come. One booklet is UEB, or UEB Math /Science, and one booklet is Nemeth Code, or UEB with Nemeth. Each listing includes the name, the print symbol, and the Braille cells that correspond to that print symbol, as well as an example. The symbols are categorized by those 3 levels. And like I said, yeah, there's a Braille version and a print version. Yay, you get to do something. Show us your flex of your UEB Math Science muscles. Which of the following is the line through previous item indicator? Is it A, dots 4, 6, 3, 4, B, dots 4, 1, 2, 4, 6, 1, 2, 3, 2, 3, 4, 5? Is it C, dots 4, 1, 5, 6, or D, dots 1, 5, 6? Which is the line through previous item indicator?
We're giving the audience just a moment to think this through. And it looks as though 87%, Kyle, went with choice C, dots 4, 1, 5, 6.
And that's correct.
Yay!
The answer choice B is an interesting one because it's the transcriber defined shape indicator followed by the letters LT, which might be a tempting construction for the line through something shape if we didn't already have a UEB symbol for it, but we do. We have a UEB specifically assigned indicator for line through previous items. So we don't need to wade into that transcriber defined shape territory. So in case you don't get all of the juice that you need from today's concentrated webinar, I mean, just in case, right? Surely we can cover absolutely everything today. No, but for real, you'll want additional study sources. Again, the UEB online math programs, they're pretty recently released, just I think last year. And there's 3 levels: introductory, advanced, and extension. They're 3 separate programs. And each of these UEB online programs starts with explanation and identification of symbols, and then is followed by at least 2 kinds of exercises. One where you 6-key enter Braille that corresponds to print, or another where you enter print, which corresponds to the Braille that's shown on the page. It's free to engage with these fully online study resources at uebonline.org. The UEB math tutorial from APH is also free and entirely online. It's also organized into lessons. This program does not necessarily, it doesn't make you log in, so it doesn't give you a track of what lesson you're on. Any lesson is available to you at any time, which can be cool if you want to just study a specific concept with some of the individual expression practices and proofreading practices that are part of the UEB math tutorial. I've made some flashcards on Quizlet. My username is Braille Trainer, and the flashcards are organized into folders. So if you, let's do it. If you go to Quizlet.com, hey, come here, and search study sets, textbooks, questions, search for Braille Trainer. Then under users, you should find me. And if you go to the view, not study sets, but folders, those study sets are organized into categories, one of which is UEB Math /Science. There's some notes about BANA recommended formats in one set, and then a bunch of symbols in another set. And what I like about Quizlet, you probably already know, is not only can you do the flashcards where you look at one side and then the other, but you can also play some games where maybe you match the Braille to the print by dragging them around the screen. Some of these games are pretty site dependent, or you can go through a quiz which asks questions like, okay, what does this? It just takes the information from the cards and rearranges it to make you answer true, false questions. And that is another way that you can practice some UEB math science material, is with those Quizlet flashcards. Because there's a lot to talk about when it comes to UEB math science, there's also various resources, including webinar recordings and sort of ask the expert options from National Braille Association, as well as CTE-BDI and VA-VF. So that's National Braille Association, California Transcribers and Educators for the Blind and Visually Impaired, and the Visual Aid Volunteers of Florida. If you're attending live today, it might be worth noting the VA-VF conference actually starts this week, is all virtual, happening on a series of 3 Wednesdays. And I am certainly going to be pushing up my nerd glasses about some UEB math science material with VA-VF. If you want to get real serious about your study, then the UEB technical course is great. You can actually get a letter of proficiency from this CNIB, the Canadian organization. They'll send, if you study through the materials, you take a practice test, and then you take a final exam. If you pass both of those things, then you get a letter of proficiency. This is currently, if you're in North America, this is currently the only way to get a really official, quote, certification. It's technically a letter of proficiency, not a certification. This UEB technical course from CNIB is currently the most official way to get, quote, certified in UEB math /science. So again, that's the UEB technical course from CNIB, and it is a self-directed course. So it's a series of examples with, like on the next page, their corresponding transcriptions that moves through the guidelines for technical material. You very much need both the guidelines for technical material, including all of its updates, and the UEB technical course materials. For more information about certification in UEB Technical, including some words from one of the designers of that program, but also about other certifications like literary and Nemeth. Last year, we did a webinar called Navigation of Braille Certification, and the information in it is still really relevant and specific. If you're looking for further certification, it's a great resource, I think. Burning questions about certification or whatever nonsense I said about terminators always ending with a .3 or grouping things, always having the Braille grouping indicators as their sort of base symbol? Okay, we still have 30 minutes. So let's drink some juice. You guys, I'm not letting go of that analogy. We're gonna look at superscripts because we see them both in literary and math context, and so we can expand out our understanding of superscripts. Before we delve into the Braille, let me take a little moment to say Happy Women's History Month. Pictured on the screen is Helen Keller in some of her later years, surrounded by children with a big smile on her face. I feel like I'm preaching to the choir here to say who Helen Keller was, but Helen Keller was a person who at a very young age became blind and deaf, who proceeded on in her life learning to read and navigate the world, as well as communicate her ideas and build up her community. So superscript, because you might say the effect of Helen Keller is exponentially increased when each of us spreads it into our own communities. If we have x squared, then we transcribe it using the letter X, followed by the superscript indicator, which is .35, and that superscript indicator needs to be grade 1ified. It needs to be put in grade 1 mode so that it cannot be misread as the in contraction. Then we have our number 2, which is our superscripted number. We only need the grade 1 for the superscript indicator here and not for the X, because the X is not standing alone. It's immediately followed by more symbols, which aren't just the punctuation or indicators that would leave it standing alone. So the X has to be the letter X. It can't be the alphabetic word sign. That's why we didn't grade 1ify it. Obviously, our superscripts can happen in longer examples as well. For example, 3x minus 4y plus y squared equals x squared. We're going to open a grade 1 passage here with 3 cells of dots 5, 6. And I'll come back to why we did that. Then we have the number 3x, our 2-cell minus. It's a symbol of operation, starts with dot 5, and then dots 3, 6. Number 4 and the letter y plus, should I say it? It starts with a dot 5, and then the plus is dot 5, dots 2, 3, 5. Y, our superscript indicator, and a number 2. Remember, we're in a grade 1 passage here, so we don't need any grade 1 indicator for this superscript. Equals, we've seen that one a lot. This time doesn't have a line through previous item indicator. And x squared, then we terminate our grade 1 passage. Okay, I will come back to the grade 1ification there, but I want to look at some more superscripts before we circle back. So 2 more examples. X superscript 15 followed immediately by Y superscript 15. We have X and then the superscript indicator. It's like a little ramp right at the bottom of the cell. It's dots 3, 5. So just a little, it goes up there. And then our number 15. We know the superscript indicator applies to an item. And we know that one definition of an item is an entire numeral. So we don't need any Braille grouping indicators here. Our superscript effect is going to apply to the whole numeral 15. But then the effect is going to end. So plop, our Y is back down on the baseline. And then we have a superscript for the last 15. We did use a grade 1 indicator here before the first superscript indicator, but then we don't need one for that other superscript indicator because the numeric indicator put us in numeric mode. And when numeric mode starts, grade 1 mode also starts. They don't always finish together, but they do. Grade 1 mode and numeric mode start together. So because of this numeric indicator, we're in grade 1 mode for the rest of the symbols sequence, and that's why we didn't need a grade 1 indicator for this superscript for the last 15. Whew. Bet you never thought you'd spend that long with a 2 variable expression. One more is where we do need the Braille grouping indicators. Here we have X with the superscript -2. So the superscript is the minus and the 2. Our item would be just one or the other, right? Our symbol of operation, that's an item. Our numeral could be multiple digits, but the numeral is one item. And so we have to group them together in order to expand the effect of the superscript indicator. If we, here we need a grade 1 word indicator so that neither our superscript indicator nor our opening grouping indicator can be misread as their grade 2 meanings, which is the contraction in and the contraction GH. So while we're talking about grade 1, let me just revisit the first Helen Keller slide and say the reason I put this second example in a grade 1 passage has to do with the BANA guidelines in the guidelines for transcribing mathematics using UEB, which recommends that we really try hard to stay out of the way as transcribers in the midst of an expression. So we can see that this first symbol sequence starts with a numeric indicator, and numeric mode and grade 1 mode start at the same time. And even though they don't always finish at the same time, they do. The grade 1 mode here established continues through that whole symbol sequence. The numeric mode finishes with the X because an X cannot be a numeral. And so numeric mode is terminated with the X. We know it can't be a numeral because it has dots in the lower part of the cell. So that's perfectly clear. So why then did I grade 1 passage at the beginning of this thing? Let's look all the way at the symbols sequence that follows the equals here. I have X squared. If I didn't open a grade 1 passage, then I would have to insert a grade 1 symbol indicator here before the superscript indicator. And that would be a little bit like me poking my head into the Braille user's computations and saying, hey, by the way. So instead of poking my head in farther on in the expression, even just for a grade 1 symbol indicator, the recommendation is to use a grade 1 passage for this entire expression. So the entire expression can be uninterrupted by grade 1 symbol indicators. When we can do it, we try to make the entire expression be uninterrupted, not have any grade 1 indicators interrupting it, which is sort of like the transcriber popping their head in and saying, oh, hey, hi, by the way. That's why we used this longer version, but that sort of gets us out of the way. I can hear you asking, would it be wrong not to use a grade 1 passage here, but instead just use the grade 1 symbol indicator for this one little superscript indicator, little ramp? No. Our goal here is accuracy of symbols, and that would definitely give accurate symbol information to the Braille user. It is next level to use the grade 1 passage here. All right, I have a question for you. Where can you, yes, you, purchase math symbol reference booklets? Can you get them from Facebook at American Printing House? American Printing House is on Facebook. Or B, from APH compensatoryskills.org, or C, from brailleauthority.org. Where can you purchase math symbol reference booklets?
See, now you're jogging our memory up just ever so slightly, Kyle, because we talked about this several slides ago. Well, I'm going to stop and share out that 88% have reported aph.org.
Yeah, that's absolutely right. You purchase things through the APH website, not through Facebook. And the brailleauthority.org is an important site, but not a place from which you purchase anything. Brailleauthority.org is the website of the Braille Authority of North America, or BANA. And that's where we would find some of our BANA published guidelines and principles. Okay, slide. Could I please have the next slide? Thank you. Here's where we're going to zoom a little bit and really condense or concentrate just quick notes about some UEB materials. We've touched on this when we're talking about grade 1 mode, whether we do it with symbol indicators or passage indicators. One of our very first concerns when transcribing, especially a UEB Math Science document, is that we want to carefully distinguish our symbols. So because a Braille symbol may have both a grade 1 meaning, like the superscript indicator, little dots 3, 5, shing, and a contraction or grade 2 meaning, like the in contraction, dots 3, 5, bing. Some symbols may also have a numeric meaning. So dot 1, for example, in grade 1 mode means A, and actually in grade 2 mode means A as well. And in numeric mode means 1. Let's talk about just one more. In grade 1 mode, dots 1, 3 means C. In contracted or grade 2 mode, dots 1, 3, 1, 4. I'm losing my mind, y'all. 1, 4 means can, right? It can be an alphabetic word sign. Or if it's a numeric mode, again, dots 1, 4 means 3. So when we're in different modes, some of our Braille symbols can have different meanings. So if we had the number 71, we transcribe it numeric indicator, dots 1, 2, 4, 5, and dot 1. If we have those same Braille cells, but a grade 1 symbol indicator before the second one, that means 7A. If we had TRAPIN and the number 2, that's everything in grade 2 and then numeric mode. But if we use a grade 1 symbol indicator before the little ramp, right? Dots 3, 5, which is the superscript indicator. Can you guess what the subscript indicator is? Yeah, you're right. It's dots 2, 6, a little ramp down. If we have this trap and then grade 1 meaning of the dots 3, 5 and the number 2, that is the superscript 2 following the word trap, right? Because we're in a different mode, grade 1 mode, for dots 3, 5, and it has a different meaning than it would in grade 2 or contracted mode. And we pay careful attention to that because we want to give our Braille users really accurate information. Last but not least, 45G. Well, in numeric mode, if we don't break numeric mode, that cell dots 1, 2, 4, 5 means 7 in numeric mode. That same cell in grade 1 mode means G. And we just need a grade 1 symbol indicator in order to change the meaning of dots 1, 2, 4, 5. Ooh, again, I get to ask you a question. Which is the best transcription of the expression x cubed or x superscript 3? I'll give you a few minutes to just look at the dots before I read anything aloud and give it away just a little.
And if the poll window tends to cover up the poll slide, you should be able to take and grab that pop-up box and you should be able to slide it over to the right so that you can then see the original slide that Kyle is trying to share.
So our options here differ in two ways. Answer choices A and B both have the letter X followed by a grade 1 symbol indicator, and then the cell dots 3, 5. Answer choice A has that dots 3, 5, followed by numeric indicator, dots 1, 2. And answer choice B has the dots 3, 5, followed by numeric indicator, dots 1, 4. Answer choice C starts with a grade 1 word indicator and is followed by X, superscript indicator, opening Braille grouping indicator, number 2, closing Braille grouping indicator. And we're looking for the best transcription of the expression X superscript 3.
And our friends here today, 90% chose answer B.
That's exactly right. And this one, I don't want to say it was mean, but it was maybe tricky because the answer isn't in the indicators at all. It's in the number. Answer choices A and C both have the number 2 being superscripted in various ways. Only answer choice B actually shows the number 3 being superscripted. And answer choice C has that numeral, the whole numeral 2 enclosed in Braille grouping indicators. We know that's unnecessary because a numeral, no matter how many digits it is an item, is one definition of item, according to guidelines for technical material. In keeping with our talk about principles and sort of concentrated ideas, here are some of the principles, the foundational concepts upon which UEB is built. And with these concepts in mind, UEB was designed. For usability by both beginning and advanced readers. Computability from print to Braille and from Braille to print, sometimes called back translation. So one of the goals of UEB is for the cells to mean the same thing, both from Braille to print, and then the goal is to get those same exact cells when you go from print to Braille. A principle of UEB is also readability. Try not to make anything need 56 Braille cells to convey its meaning. Try to keep things concise and readable, as well as being specific in order to be readable. And lastly, for now, compatibility with technical material. So if you're transcribing something in literary and feeling a little taxed by how often you have to use grade 1 mode, it may be because of rules that allow for technical material to be transcribed using exactly the same symbols and just building off of the rules that are used to transcribe literary material. It's all one code, from beginning to advanced, from literary to math, and back again. I've kind of said this a couple of times, and I want to take this moment to dedicate to saying one more time, before we get caught up in which kind of grade 1 indicator I should use, or whether I need a Braille grouping indicator or not, our goal is always to get our cells accurate. And then we can move on to next level of formatting or a specific kind, a specific style of indicator. We want our content to be really, really accurate before we move on to anything else, like where things should go on the page. Okay, so our takeaways from today. Quote, UEB Math/Science and the guidelines for technical material, or GTM, they're not separate from UEB. Anything that's math and science is a further extension of the fully unified English Braille code. the line through previous item indicator, which is dots 4, 1, 5, 6. It's out there, and you can apply it more accurately and confidently now that we've talked a little bit about what an item is and how the line through previous item indicator can work for us in spatial material and for the not equal to operate or comparison symbol. And APH does have these math symbol reference booklets, just little spiral bound guides that are some convenient and concise resources for looking up UEB math science symbols and seeing them in a little bit of action. Next month, we're going to do another sort of concentrated webinar, that one focusing on Nemeth code. So that's called UEB with Nemeth Boolean cubes. That'll take place April 25th from 12 to 1:30. You can register, you'll be able to register from the Access Academy site. I have more material, but I want to take this moment to pause and see if there are any burning questions or specific stories.
Currently, there isn't anything in the chat. We have kept up with just reposting some of the links, and it's been rather quiet. I think that you have all of our undivided attention with what you're sharing about. So what I would say is that we will go into this bonus information. I want to share that with our captioner, please feel free captioning to excuse yourself at the bottom of the hour. You can close out your file. I will post in the chat window the closing code at the bottom of the hour too, in case we might go just a few minutes over. Again, this is recorded so that you can always go back and snag this recording to see any of this bonus information that you may have missed. And I think that we will go ahead and I'll attend to some chat window conversation if you want to continue to take it away, Kyle.
Okay, will do. I do have a couple of polls here that I think will be fun for the people who are still here. That's the start of the bonus material. Yeah, well, y'all can please go check out the UEB math tutorial from APH and play around with its exercises and proofreading examples. Fractions are a great concentrate whose principles extend out into lots of applications. So those fractions are covered in lessons 4.2, 4.3, and 6.4 of the UEB math tutorial from APH. For those of us who are here live today, let's do another question about which is the correct transcription of the expression bar over AB not equal to bar over CD.
We'll give you a moment to think that through, and then we'll read through those choices. And it looks like we have 9 minutes to go.
So your answer choices differ in one significant way. Answer choice A has a grade 1 passage indicator followed by all caps AB in Braille grouping indicators, and then the indicator dots 1, 5, 6. The symbol of comparison is the same in answer choices A and B. Answer choice B doesn't have any grade 1 indicators. Answer choice C has the symbol of comparison dots 5, dots 2, 3, 5, 6. And as I said, answer choices A and B both have the symbol of comparison dot 5, dots 2, 3, 5, 6, dot 4, dots 1, 5, 6. Answer choice Yeah, answer choices C and A are the same except for the symbol of comparison. Answer choices A and B are the same except for the grade 1 passage. So I see answers are 62% choosing A, still 29% at B coming in second, and just 10% chose answer C. So the correct answer is A. And the reason we need the grade 1 passage here is that our opening Braille grouping indicator has a grade 2 meaning, and that's GH. So without the grade 1 indicator here, we have GH, cap, cap, AB, AR, WH. But with the grade 1 mode, we have the capital letters AB made into an item with these Braille grouping indicators, and then the line over previous item indicator. And then let's not forget our print has the not equal to comparison sign, and that's 4 Braille cells. It's the equal symbol, dot 5, dots 2, 3, 5, 6, and the line through previous item indicator, which we've gotten to know a little well today, and that's dots 4, dots 1, 5, 6. So A is the correct answer. Most of you got it very nicely. Again, the bar over previous item is different from the line through previous item, and the bar over is simply dots 1, 5, 6 when it's in grade 1 mode, right? Otherwise, it's WH. And that bar over previous item is part of the section 12 in Guidelines for Technical Material, which is called something cute like bars, lines, and more over and under. Another possible over or under application is to not group together the A and the B. We talked about this previously with our bar over indicator. If we don't have the Braille grouping indicators, then that bar over can only apply to the previous letter, just which is the previous symbol in the symbols sequence. That's why we need those Braille grouping indicators for these 2 letters. They expand the effect of the line over indicator. We have time for one more poll.
We will squeak it in.
Let's do it. Which is the correct transcription of 72G? This is a lowercase g following the Arabic numerals 72.
See, once again, you're jogging our memory from a few slides ago.
The answer choices are A, which is numeric indicator, dots 1, 2, 4, 5, dots 1, 2, dots 1, 2, 4, 5. Answer choice B is a grade 1 symbol indicator, numeric indicator, dots 1, 2, 4, 5, dots 1, 2, dots 1, 2, 4, 5. And answer choice C is numeric indicator, dots 1, 2, 4, 5, dots 1, 2, then a grade 1 symbol indicator, dots 1, 2, 4, 5.
And
overwhelmingly.
That was exactly the word I was thinking. Overwhelming. 96% chose C.
Absolutely. Without our grade 1 symbol indicator before that lowercase g, why that Braille cell configuration would mean the number 7, because it would still be in numeric mode. But if we dots 5, 6 it, we put it in grade 1 mode and allow it to have the meaning, the letter G. Interestingly, if we had a capital indicator, that would terminate numeric mode, not grade 1 mode, but that would be fine for if we had 72 cap G. We wouldn't need a grade 1 indicator for 72 cap G because the cap does the work of terminating numeric mode. And that's really it. Let's stop. Hurry, quick stop before we can't stop.
I think this was absolutely marvelous. I love, Kyle, your command over the content. It is difficult information to take in to a brain, but I love how you give it such style and make it so engaging. You're teaching us so many things, building upon things that if you caught us last year in 2021 for the Come Back to Me Braille series. We just added upon that. Maybe we have piqued your interest by mentioning that and saying, hey, go over to our archives to Access Academy and see what we mean about that. But what you are advertising right here, Kyle, is that in a month on April 25th, we will be doing UEB with Nemeth Boolean cubes, another concentrated method of showing the principles of how to use Nemeth within UEB context. And that will also be a 90-minute webinar from 12 to 1:30.